Unreal Engine is one of the most powerful, fun, and versatile game engines publicly available. It may seem intimidating or even overwhelming at first, but this course is set up for all skill levels to guide you through every step of creating a full-fledged survival horror game, start to finish. This is the game engine that gave us Fortnite, the Batman Arkham games, Senua's Sacrifice, and many other critically acclaimed games. Both Unreal Engine 4 and Unreal Engine 5 users should be able to follow along, as we are here to learn the basics of creating a video game, going all the way up to advanced horror mechanics such as health, flashlight systems, jump scares, highly robust interaction systems, advanced inventory with item inspection, cutscenes, AI enemies, and much more. We're even going to check out how to recreate some features from your favorite horror games. In this course, we'll be using Unreal Engine's visual scripting system, Blueprints, a system that's incredibly powerful while also being very fast and easy to use. You'll be surprised how quickly you can start creating games, how fun the process will be, and how efficiently you can go from knowing nothing to being confident as a game developer. Please join this course now. Hi everyone, and thank you for purchasing this course. We're going to just jump right in. I will assume you already have the Epic Games Launcher downloaded, and if so, we just have to launch our engine. For this project, we're going to be using the blank template. Let's hit next, and we want it to be Blueprints, maximum quality, ray tracing disabled, desktop/console, and we can go ahead and include the starter content. I'm going to rename mine to Udemy Horror Game. Can't type today. And you can select here where to save your project. I will be saving it in this folder right here. And go ahead and hit Create Project. Alright, so now we're all loaded in. One thing I want to do is, for me, SteamVR always opens automatically when I create a new project, and it will continue to do so every time I open it. To disable that, I'm just going to go to Settings, Plugins, and search for Steam VR, and disable it. The editor has to be restarted before the plugin takes effect, but we'll just let that happen next time we open the engine. So, what we want to do first is create a new level. We don't want to work in this default level, we want our own. So let's make a new folder called Maps, and File, New Level. Let's choose Default, so we still have our lighting and Skysphere, and we can hit Save, choose our Maps folder, and we will call it Level 1. And before we get started, I want to add a post-process volume to disable the exposure. If we hit play and look at the ground, you're going to see it start to light up very bright. And it'll start to darken again as we look at the sky. I want that disabled by default. We do that with the post-process volume. So search post-process, drag in the volume, and now everything inside this box will have our post-processing. So we take our exposure, we can go down here and see the min brightness and the max brightness. It's 0.03 and 2. We can just check those and set them both to 1. So there'll be no difference when looking down and looking up. Now there is right now, and that's because we're not inside our post-process volume. So if we go inside, and we look down, it doesn't brighten, nothing changes. Now, we want to make this unbound, so we search for unbound in here, infinite extent, and we check it. And now, we no longer have to be inside the box for this to take effect. We look at the ground, and it doesn't brighten. Now it affects the entire world. The box has become obsolete. Great, so we've set up a small level for us to work in. Next episode we'll be working on game instances. So first, let's talk about game instances. A game instance spawns when the game starts and is deleted when you close the game. It goes between levels. It doesn't get reset when we open new levels. It can be accessed from any blueprint, and it is perfect for storing global data. For example, if you're making a single-player game with multiple levels, you could store, say, the player's health in the game instance, so the value is carried on from one level to another. And that's just a small example. There are many, many things you can do with a game instance. So let's make one at the moment. So let's make a new folder, and we'll call this Game BP for Game Blueprints. And let's go here, Blueprint class, and we want to open up all classes here and search for instance. And here it is down here, Game Instance Select. And we can just call this HG for horror game, game instance. Save. Now we have to add our game instance to our world. We have to let our world know that this is the game instance we want to be using, not the default one. And we do that in our project settings. So if you go up here to settings and click project settings, here we have a long list of settings that we can access. Now if we go down to maps and modes, there is a game instance class right here at the bottom. Click on that and choose our new HG game instance and close that. Perfect. In the next episode, we will be talking about the game mode. A game mode stores a level's information, like what pawn, controller, game state, and HUD class we're using, and we'll talk about all 4 of those in later episodes. Game modes are spawned when a level is opened and removed when a level is closed, unlike a game instance which goes across multiple levels. In multiplayer games, the game mode controls how many people log into a level and how they join, as well as stopping players from joining or knowing when players leave. Another important thing to point out is in multiplayer games, only the server has access to the game mode. Since this is a single-player game, that's not necessarily important for our project. So let's make another folder inside our content game blueprint, and we'll just call this level 1 for our level 1 level. And we can open it up. And inside this, let's make a game mode. So let's go to Blueprint class, and right here we have game mode base. We can click on it, and we can call it L1 for level 1, and game mode. So let's assign this game mode to our level. We can do that right here in our World Settings tab. If you don't have it, you can go to Window, World Settings, right here. And we have this thing called Game Mode Override, and it says none for now. We can open this up, and we can see our L1 game mode right there. Let's click it. Now if we expand our selected game mode here, we have a few things, like our default pawn class, our HUD class, our player controller, our game state, our player state, and our spectator class. These things are the kind of information that our game mode holds. Now every single level needs a game mode attached to it. If you notice, we can remove it, and it says none. If it says none, it will use the default game mode. To find what the default game mode is, we can go to Settings, Project Settings, and Maps and Modes. And here we have the default game mode, which is just the regular game mode base. If you want, you can make it the L1 game mode, and the none will default to the L1 game mode. I'm still going to use the game mode override for L1 game mode. All these things in the selected game mode are going to be future episodes, and we'll talk about each one. Game states are similar to game modes, but in multiplayer games, both the server and the clients have access to it. If you remember in our last episode, I made sure to point out that the game mode, only the server has access to it. In multiplayer games, game states hold level information such as world time or the current goal of the level. And since we're making a single player game, we'll just keep most of that information in our game mode. So let's make a game state now. So we can right click. Right now we're still in our content, game blueprints, level 1 folder. And we can go to blueprint class and search game state. And we want to choose game state base, not game state. Click that, select. And we'll call this L1 game state. Let's go ahead and add this game state to our game mode. So we open this up. And over here, under classes, we have our game state class right there. we can now select our L1 game state. Perfect. In the next episode, we'll be going over our player state. Player states are like game states, but instead of one per level, there's one per player per level. Once again, since this is a single-player game, separating the game mode, game state, and player state doesn't have too much importance. Player state is used to store things like the player name, their high score, numbers of kills/deaths, etc. Let's go ahead and make one. So right-click, Blueprint class, and we want to search for player state. It's right here under Info. Select, and we will call it L1 player state. Once again, to let our level know that this is the player state we want, we have to add it to our L1 game mode. So open it up. Right here it says player state class. Click on it, and we can choose L1 player state. Alright, the HUD class. This video will be very short because the HUD class in Unreal Engine is not really used anymore. I'm only showing it because I occasionally use the HUD class for debugging, but our entire user interface will be powered with UMG, which we'll go over later. So let's just create a HUD class right now. So Blueprint class, search HUD, we want to choose this first one right here, and we'll call it L1 HUD. And like always, add it to our game mode, right here, HUD class, L1 HUD. And that'll be it. Alright, player controllers. You can think of the player controller as the brain that drives the player character. A controller can possess or unpossess different characters or pawns, and that becomes the new body to our brain. Another way to think of it is the player controller you can imagine as you, the player, and the character as the actual character in the game. The player controller will handle anything that would be the same no matter what character you're possessing. For example, if every character you possess uses WASD to add movement input, you could keep that in the player controller. So let's create one now. We want to go out of our level 1 folder and just into our game blueprint, because we'll be using the same player controller for every level. So let's go to Blueprint class, and player controllers right here under Common Classes. Select it, and we can call it HG for horror game, and make that capitalized. Player controller, and hit save. We want to add this to our game mode. So open up L1 game mode, and right here under player controller class, we can change it to HG player controller. Once we create our player character, we'll come back to the player controller and we'll add some control functions. So player characters are what we mentioned earlier in the last episode. The player character is the body that the player controller controls. We keep our camera and our mesh in the player character. We could also have created a pawn, which are similar to characters, but the character is a type of pawn that has the ability to walk around built in. And we want to include the ability to walk around. So let's create a character. So back in our level 1 folder, let's right click, create a blueprint class, and right here under common classes we have character. We also have pawn, which I just mentioned, and if you read here, it's an actor that can be possessed by our controller and receive input from a controller. And our character is a type of pawn that includes the ability to walk around. So let's click character, and we'll call L1 character. Let's go ahead and open him up. And the first thing we want to do is add a camera for our view, since we are making this first person. So let's add a component and search for camera. We want to choose the regular camera right here. And we want to put this kind of at the top, about where our character's eyes would be. So you can just drag it up, and I will keep it at a value of Z60. So let's compile and save, and let's add our character to our game mode. I already have it open, but it's right here in our Game Blueprints Level 1 folder, and open L1 game mode. And right here, under default pawn class, we can choose L1 character. And we can compile and save. Great, we filled up everything we need right now in the game mode. So if you remember correctly, our game mode is set to this level that we're in, level 1, because we put it in our game mode override in the world settings. It's also our default game mode, so if this were to be none, it would still be our L1 game mode. Let's just go ahead and select that again. Our L1 game mode lets the level know that our character is our L1 character, our HUD is our L1 HUD, our player controller is our player controller, and so on and so forth. So now, when we hit play, we are now playing as our L1 character that we just created. Notice that I cannot walk around and I cannot look around because we have not implemented any code that tells our character to walk around when we hit the WASD keys or look around when we move the mouse. Now to prove that this was our character, we can go into our L1 character, event graph, and here on the begin play, we can print a string, and we could say, this is our L1 character. Print strings are a great way to debug. So if we hit play again, in the upper left, we can now see this text is kind of covered up by our click for mouse control. But it says this is our L1 character in blue. It would not say that if we were playing as a different character in our game. Now you have a good understanding on setting up for a game and a bit on what classes do what. Next up, let's actually give us the ability to look and walk around. Alright, so first off, let's add some camera movement. We're going to add mouse control for camera movement in the player controller. So we can open up our player controller right here. This is where we will be writing out our blueprints to allow our mouse to control where our camera will look. But first we need to add some inputs for our mouse. So if we go to Edit, Project Settings, it's the same as going to Settings here and clicking Project Settings, which we've done in earlier episodes. Same thing. We can scroll down and find Input right here. And we have two types of inputs, action mapping and axis mappings. We're going to be using axis mappings because they can have scales, and I'll show you how we're going to utilize that in just a second. So let's add two. I just clicked that twice and it added these two new ones. And we can call them look up and look right. Now we don't have to make ones for look down and look left, because what we're going to do is for look up, we obviously want our mouse Y. So when we move our mouse up and down. Now in look right, we want to use our mouse X. So when we move our mouse left and right, or when we move our mouse right, it'll look right. Now, the mouse Y is actually reversed by default, so we actually want to set the scale to -1. This way, moving our mouse up will move our camera up, and moving it down will move it down. If we left this at 1, moving our mouse up would move our camera down. So we can go ahead and close that. So before we add our blueprints, it's important to go into our L1 character, which is just here in our level 1 folder. And we want to click on our camera, and we want to check this right here, use pawn control rotation. Check that. Compile and save. Now in our controller, we want to add our inputs. So input look up and input look right. And these are the two we just added. Now if we look up, we want to add pitch input. And the value will be our axis value. For look right, we want to add yaw input. Same thing, axis value will go into our value. So our axis value is our scale that we added. Remember, for look up, we set it to -1, and look right, we kept it at 1. So if we move our mouse on the x-axis, and we move it right, that'll give us a scale of 1. If we move it left, it'll give us a scale of -1. And that's how we know to add yaw input for both left and right when we move our mouse this way. Same thing with this. So instead of just me explaining it to you, we can actually hit play and see if it works. Look at that. Moving our mouse up moves us up, down moves it down, right moves it right, left moves it left. But it's very sensitive at the moment. Very slight mouse movements are moving the camera a lot. And this is a mistake I actually see a lot of indie developers do. They don't really consider going past this, and sometimes it becomes very hard to control, and it's a little bit of a grievance. So, in our player controller, we want to create a variable for sensitivity, and we will call it look sensitivity. You could create 2 of them, one for the x-axis and one for the y-axis. It's up to you. We want to make it a type float, compile and save, and I want the default to be about 0.4. So to use this, we want to multiply, get a float by float node right here, multiply the axis value by our look sensitivity, and plug it in right there. This is where you could use a separate variable for the y-axis and the x-axis if you want, and plug it in like that. So now it'll multiply our axis value by 0.4, so we're only taking 40% of just our raw axis values, and only plugging in 40% of that to our pitch and yaw input. So now if we hit play again, the camera, I can move my mouse a lot further with the camera being slower. And that feels a lot nicer, a lot more natural. Okay, now let's give us the ability to walk around. Because at the moment we can look around, but I'm pressing the WASD keys and we cannot move. So we need to add more inputs. So let's go to settings, project settings, down to input. And these will also be axis mappings, so that we only have to use 2 instead of 4. So we will call one move forward and one move right. Now for move forward, we want to use our W key. So right here under keyboard, we want to select this one that says W. And we want to add one for S as well. So right here, next to the move forward, there's a little plus button, and we can add a second button. And we can type in S. I'm going to just close this gamepad, and under the keyboard, we can find S right here. Change this scale to -1. So pressing W will give us a scale of 1, and pressing S will give us a scale of -1. So with move right, we're essentially doing the same thing. We want the D key to move us right, so close gamepad, under keyboard choose D, and add another, and this will be A, right there, and this one will be a scale of -1, and close that again, save, and we're going to put this one in our player character, so we'll open up L1 character, and we can just delete these 2 events right there. And we want to right click, and we want to type in input move forward and input move right. Okay, and we want to get a node called the add movement input. The scale value will just be our axis value right there, and our direction will be our get actor forward vector. So it'll be wherever our character is facing forward, pressing W will move him in that direction, pressing S will move him in the opposite direction, so backwards. We can just also add movement input for move right here, axis value into scale value, and get for roll direction, we want get actor right vector. So similar to the forward vector, it will just take it 90 degrees away from our facing forward, so right, and -1 will make us move left. So we can compile and save, and we can actually test that out, and now pressing WASD has us move around. Great. If you want to change the speed of which you can move around, we can use the character movement right here, which is built in to our character class. If we go down, walking, under walking, there is a max walk speed right here, and this will be our walk speed. I'm going to change mine from 600 to 400. This is a horror game, so I kind of want his walking speed to be a bit slower. Great. In the next episode, we will be concentrating on jumping. Alright, let's give us the ability to jump. This will be a relatively short episode because we're going to be using Unreal Engine's built-in jump function. But we still need a input, so like always, go into Settings, Project Settings, and down to Input. And this input is actually going to be a action mapping, because we don't really have to worry about the axis value of anything. It's just whether the button is pushed or not. So we can call it jump. And I will make it spacebar. Now the handy tip for making inputs is if you want to make something controller based or something, you can just add right there, and you could make another button for it. Gamepad face button bottom. So for example, on Xbox controllers would be the A button, on a PlayStation this would be the X button, etc. And you can just add as many as you want. I'm just doing this on keyboard, so I'm just going to keep it all keyboard. So we can close that. We can go into our L1 character and right click, and we'll call input jump. And off pressed, we're just going to call the jump node right here. And on released, we will call stop jumping. So it's as simple as that. We can press play, and when we press our space bar, we now jump. Great. If you want to change the height of your jump, we once again do that in our character movement right here. And if we can find it, it's jump Z velocity right here. I'm going to change mine from 420 to something like 400. Just a bit more of a hop than a jump. Great. That looks good to me. Alright, now that we've got our game to a playable state, let's add a interaction system. Interaction systems are obviously something you see in plenty of horror games, if not all of them. So first thing we want to do is go to Edit, Project Settings, and down to Input. And we want to add another action mapping. And we will just call this Action, and assign it to our E key. Close Gamepad, and click it right there. And we can close that. So what we want to make is what's called a blueprint interface. So let's make a folder called blueprints. And inside that folder, let's make another folder called interfaces. Right click, and under blueprints here, we want to click blueprint interface, and we will call it BPI for blueprint interface interaction. So let's go ahead and open that up, and we want to give it a function. We'll call this function interact. And that is everything we need to do in the BPI interaction. So we can close it. I'm going to go ahead and close our player controller as well, and our game mode, since we won't be needing to use those for a while. Excuse me. So in our player character, we want to make a function for a line trace. So we're going to call this line trace, and we want it to have one input, and this will be the length of our line trace. So essentially what we're going to do with this line trace is, oh, and make it a float, by the way. And what we're going to do with this line trace is we're basically casting out a line from the center of our camera out into our world, directly forward. And with this length input, we will choose how long that line is. And if it, for example, if it hits something with our BPI interaction, our interface, then we can tell it to do something to interact with it. But we're creating a function for the line trace itself, so we can reuse this same line trace without having to repeat the code over and over again. So drag off here, we're going to search line trace by channel. So we have a start and an end, our 2 points of our lines. For the start, we want to grab our camera, pull it into right here, and get world location. So we want to get the world location of our camera, and that's our start. For the end, we want to get the camera's forward vector, and we want to multiply that by a float. This number will be the length of our line, so we can just plug in our input right into there. Then we have to add these two together so it's positioned correctly. Not a vector plus float, but it will be a vector plus vector. Plug it in right there. And that will be our end location. Now we want to break the out hit. And here we can access a bunch of different information about what we hit. We want to create an output as well for our function. And we will call this hit actor. And this will be of type actor, object reference. And we can just plug in hit actor right here into hit actor right there. Compile and save. Now back in our event graph, we can create a input action. So this is the input we just created. It's bound to our E key. So every time we press E, this will fire. So every time we press E, we want our line trace to be called. I'm going to make the length of the line trace 350. I feel like that's a good length, a good reach for our character. And basically, we want to call this function interact if we hit an object that has our BPI interaction attached to it. So what we could do is just drag off hit actor and type in interact. And you can see under this class BPI interaction, we can call the interact message. So whatever actor we hit, it'll call this interact message. But we don't want this message to call every time we hit an actor. We only want it to call when we hit an actor that has this interface bound to it, and we want to make sure we did hit an actor at all. So we can just create a branch before this, and we want to get if the actor is valid. And we also want to check, create an and boolean, if the hit actor is implementing, or is it just does implement interface, not is. And the interface we want to choose is our BPI interaction. And we can plug this right into our condition. So if both those things are true, it'll call this interaction or interact message. So compile and save. So let's create an object that we can interact with to test this out. So if we go back into our blueprints folder, I'm going to create another folder called actors. And I would just create a blueprint class of type actor, and I'll call it BP interaction actor. So open that up. And the first thing is we have to assign our BPI interaction to this. So here in class settings, right over here, we have interfaces, implemented interfaces. And right now it says no interfaces because it doesn't have any by default. We can just click this little add button, search for BPI interaction, and select it. Now it is bound to this actor. So you can also see over here on the left side under interfaces, we now have this interact function that has just become available after we added it. So if we right click on it and we click implement function, this right here is going to be called, this is the event that's being called from this message. So if we hit this specific actor, it checks if it implements the interface, which it does. It checks if it's valid, which it is, and it'll call interact. So interact right here will be fired. We can test this by creating a print string, and we can just type in something like, we hit our interaction actor. compile and save. Let's also make sure we actually have something to hit. This little sphere here is not physical. We will not see it in the game. So let's go ahead and add a cube, just so we have something to actually interact with. And we can go and drag this out into our world. Let's bring it up a bit. And let's hit play. So when we hit E, nothing happens, because we are not actually hitting an actor. Now if we hit this actor right here, it now says we hit our interaction actor. To make this a bit more clear, if we go back into the L1 character, and if we go into line trace right here, we have this draw debug type. We can change it from none to for duration, and this will actually show us the lines coming out of our camera into the world. So if we hit E, and kind of move away so we can see it, there's this very thin red line that'll be there for a few seconds, and now it's gone. You can see the length of it too. It's 350 units, because that's what I set our length to be. And we can interact with things like the ground, but that doesn't do anything because we have not set our interaction interface to it. But if we hit our cube, once again, we now see we can hit our interaction actor. So to make this a bit easier as we use this line trace function many times in the future, let's make the debug type also an input. So we can just drag this off here and just release it onto our line trace execution node there. And we now have our draw debug type. So we compile and save, and back in the event graph. Now every time we call the line trace, we can, for debugging, choose what kind of debugging we want. We can change this back to none, as we don't need it anymore. Now, in the future, we can actually make our interaction actors children of this specific interaction actor, so that we can put kind of global code in our interaction actor, and it'll all be carried down into its children. For example, in the begin play, we want to cast to our L1 character. This is going to come up in the future, so you don't have to worry about it right now, but let's go ahead and do it so we can cast to L1 character. For the object, we have to get our player character, and then as our L1 character, we can pull this out, click right here, promote to variable, and we will call it player ref for player reference. And we can compile and save. In the future, some of our interaction actors will need a player reference. So it's much better if we make one here in this parent actor so that we don't have to recast to the character for every single interaction actor that we need it for in the future. This will become more clear as we actually get to that part in our series. But for now, that's all we need to do. So great. Now we have our interaction system. Any actor that we assign our BPI interaction to, we can call this event interact from, and we can tell it to do whatever we want. You might have noticed that it's a little difficult to gauge where exactly our line trace is coming from. It's coming from the center of the camera, but obviously it's with the naked eye, it's kind of hard to gauge exactly where the center of the camera is. And this is why we have crosshairs. So we're going to be adding a crosshair to our scene in this episode. So we have to first import a crosshair texture. I went ahead and made one that I will provide in the resources tab of this episode. So once you have that downloaded, you can right click. We'll create a new folder, and we'll call this textures, and import, and go ahead and import the crosshair image. Then we can open this up, and it looks really bad here, obviously, but that's because it's a 5 by 5 pixel image exploded to a 900 by 900 pixel image. But over here in the compression settings, we want to change this to user interface, and we want to change this texture group in level of detail to UI. So we can hit save and we can close that. So in content, let's go ahead and create another folder and we'll call this UMG. Open it up and we want to go to user interface widget blueprint right here. And we'll call this W main HUD. Our main HUD will contain most of all of our HUD elements that we'll see on screen when we play. So we can open this up. And back in here, we want to create another widget blueprint. And this will be called W crosshair. And this will be the widget where we put the crosshair in directly. So we can open it up and we have this screen here, and this represents our player screen. But we don't want this to be set and laid out like a player screen is. We want it its own custom size. So up here, where it says fill screen, we want to change this to desired on screen. This will still leave this box to let us know how big our screen actually is, but if I hover over the canvas panel here, the actual size will depend on what we put in the widget. So we don't actually need the canvas panel here. We can delete it and instead just add a size box. Now, if you remember me mentioning, the image of the crosshair is only 5 by 5 pixels. So here in the size box, we can check the width and height override, and we can change these both to 5. Great. And it's pretty small, but we can zoom in, see this is a 5 by 5 pixel box. Next, we want to add a image and put it in there. And here under brush, we can change the image to our new crosshair texture. There it is right there. We can press compile and save. Now let's add our crosshair to our main HUD. So we put on our main HUD, close this. Down here under user created, we can see the widgets we've created, including an animation sample UI, which we did not. We can just drag our W crosshair in, and it is not the right size. So we want to change the size X and size Y back to 5 and 5. Now we have a tiny little crosshair, but it's not centered. We'd like it exactly centered in the screen. And there's a good trick for this. So first thing we have to do is anchor it to a position. We have a few different options. And obviously we want to anchor it directly in the center. This will change this little anchor icon to let us know where the anchor is. Now, if we set the position X and Y to 0 and 0, it will not actually be centered. As you can see, it's a little to the right and a little to the bottom. That's because our pivot point of our icon right here is on the upper left side, and we want it directly in the center. We can fix this by right here in the alignment. See how it's 0 and 0? If we change this to 0.5 and 0.5, it is now perfectly centered. These two are values from 0 to 1 to let us change where the pivot point is of our icons. Now we can press compile and save. So now here, if you notice, we didn't delete the canvas panel and we kept this one on fill screen for main HUD because this one will fill our entire screen. And we have our little crosshair right in the center to let us know where the center is. But we still need to add this widget to our character, because if we hit play now, our crosshair is not there, and that's because this widget is not assigned to anything. So open our L1 character, and we want to create another function, and we're going to call this initialize. And this will be called at the begin play of our character. So if we go up with the begin play, we still have our string here saying this is our element character. We can delete that, and we can add our initialize function. Now in our initialize function, the first thing we want to do is add our widget. So we can call a create widget. Down here we want to select our main HUD. We want to create a variable for our main widget because we'll have to reference it quite often in the future. So promote to variable. And we'll call this main HUD ref. And from main HUD ref, we want to add it to our viewport. Cool. So now when we hit play, it'll call this initialize function, and our main HUD should be on our viewport, and you should see a little crosshair appear in the center. And there it is. We have a crosshair in the center of our screen. Okay, let's give us something more fun to interact with than just this cube that doesn't actually do anything. And that thing will be doors. For the mesh of the doors, we're going to use the one provided in the starter content. If you open starter content, props, we have a SM door and an SM door frame. Before we use them, we can drag them out in the world right now. You'll notice that, well, the SM door frame is fine. The SM door, for some reason, doesn't actually come with a collision. We can walk right through it. And if it doesn't have a collision, that means we can't interact with it with a line trace either. So we have to add our own collision. Luckily, we can do that inside our UE4 engine. We don't have to open it in Blender or Maya or anything like that. So let's double click the SM door. And if we click here up in collision and choose simple collision, we can see nothing's changed. And this proves that we don't have a collision. Let's leave it on actually. So if we go up here to collision, we can choose add box simplified collision. And now we get this green box that is our collision, and it automatically fits it to the lengths of the mesh. If we look at it from top view though, change it to top view, and I'm going to change this back to lit, it extends it to the doorknobs as well. And I don't want it as far as the doorknobs, since we're just working with a simple collision right now. I don't want it to come out that far. So we're going to decrease it just a bit. So if we scroll down here in the details panel, under collision, primitives, boxes, see it says one array elements because we just added one, and open it up. We can change this X extent to 5. As you can see, that is the X extent of the door. So the doorknobs will not have collision, but that's okay with me. Now if we hit play again, you can see we can no longer walk through our door, and our interaction system will pick it up. So let's make the actual actor for our door here. So let's open blueprints, actors, and we want to make a child of this BP interaction actor. We can actually make a new folder, and we will call this interaction, just so we can organize specifically our interaction actors inside this folder. So right click, create child blueprint class, and instead of child, we'll call this door. So BP interaction actor door. And I'm actually going to remove the actor part of this just to make it a little cleaner. It doesn't take as much space. Great. So we can open that up. And instead of our cube, we want this to be our door frame. Great. And we can click this yellow arrow right here to reset it to its default material, M-frame. And obviously we need a second mesh for the door. So we'll add a component, and we'll search for static mesh. And we'll make it a child of our cube, which we can rename if we want. So not all of them is called cube, and we'll just call it static mesh. So now it's called static mesh, and we'll have to rename this one. Static mesh 1. And we'll make it a child again. Compile and save. Now for this static mesh, we want to add our door. And it's a little off-centered because that's just how the pivot points are. So we have to move this 45 units on the Y, if I remember correctly. Yes, that is correct. And that's how we properly center that. So in our event graph here, we want to right-click on the interact. This actor already has the BPI interface. It says no interfaces here. But that's because it takes it from the BPI or BP interaction actor because this is the parent of this, which is why we still get the function right here. So we can right click and implement function. So when we interact with this, it will do something else. So we can print a string, and we can say, now we're interacting with a door. Compile and save. And we can delete these meshes right here and just drag in our actor. When we hit play, if we interact with our interaction actor, it says the original. We hit our interaction actor. And if we interact here, now we're interacting with the door. Just show you how it works. So let's delete that print string and let's change it to a timeline. And we'll call this open door TL for timeline. So let's open this up. And first thing we want to do is change the length. This is in seconds. So this is how long we want it to take for the door to open. I usually go for something like 0.2 seconds or 0.25, but since this is a horror game, I like it a little slower, such as 0.5. So we want to add a float track, and we're going to call it alpha. And we right click, and we want to add 2 keys. Now we want this to go from 0 to 1 over our half a second. So let's take our first key, and let's set the time to 0, and let's change the value also to 0. So second key, the time is 0.5, so the end of our timeline, and our value is 1. Now this goes way off the screen, so we can't access it anymore, but we can fix that by clicking these 2 icons, which will zoom to fit horizontally and vertically. Now if we select both and right click, we can change this from a linear interpolation to an auto interpolation. This will give it a much smoother and a much more natural feel. You'll almost always want this kind of interpolation over a linear. So let's go back in the event graph. So we need to translate this graph into the door opening. So on the update, we want to rotate this static mesh by 90 degrees. So if we just rotate in here 90 degrees on the z-axis, that's what we want it to do over the course of 0.5 seconds. So we can take the static mesh and we want to set the relative rotation, and we can plug that into update. Now we don't want to update all 3 of these. We only want it to rotate on the z-axis. So we can do 2 things. We can either right click and split the struct pin. I'm going to recombine that real quick, or we can drag it off and type make rotator. It's essentially doing the same thing. It's just personal preference most of the time. So we only want to adjust the Z, and we want to adjust it by 90 degrees. Our alpha here goes from 0 to 1. So we're going to do this with a lerp, which stands for linear interpolate. And this alpha here also goes from 0 to 1. So we can plug the alpha into the alpha. So over time, this 0 to 1 will translate to this 0 to 1 over 0.5 seconds. And we want it to go from 0 to 90. Or was it negative 90? We can double check real quick to see what we want. Negative 90. Alright. So let's just add a negative 90 in there. So compile and save. So let's go ahead, and our door's already in our scene. Let's hit play. And let's interact with it. Press E, and it opens towards us. Now if we press E again, nothing happens. And that's because we've already opened it, and we didn't set a way to close it yet. So to do that, we need to add a boolean, and we'll call it door closed. We'll call it is door closed. And here on the event interact, we want to ask if the door is closed. Now if it's true, we obviously want to open the door. So we will plug that into play. And if it's false, we want to close the door. So we want to play this in reverse. Luckily, we have a reverse right here. But before these two, we also need to set is door closed to the opposite. So if door closes false, right before we go to play, we want to set it to true. Oh, my apologies. If it's true, we want to set it to false. And if it is false, we want to set it to true and call the reverse. So now, if we compile and save, hit play, let's go around. And if we hit E on our door, it opens. If we hit E again, it closes. Perfect. And you can kind of tap it and it'll start from the position it's at rather than jumping to the end. And that's because we have it on play in reverse rather than play from start or reverse from end. Lastly, you probably didn't notice because you can't see my fingers, but it took me, I had to press E on it twice to open it. If you could hear it right there. And that's because is door closed should be set to true by default because it is closed by default. So the first time I hit it, it was seeing that it was false, and then it was setting it to true, and it was trying to reverse, but it was already shut, so nothing happened. So now it only takes one hit to open and close it. Perfect. But the only problem with this door is that it always opens in the same way. For on this side, when we press E, it comes towards us. So in the next episode, we're going to be making a version of this door that will always open outwards. Alright, so now let's make a door that always opens away from you. This one is obviously slightly more complicated, but I definitely think it's worth it, as doors always opening away from you definitely feels a lot nicer in games. So we can take our interaction door right here, and we can right click and duplicate it, and we'll call this outwards door, and we can open it up. So a good amount of this code will be the same, like the timeline that opens the door. You can change this if you want to change the time or whatever. But basically we just need to calculate which side of the door we're on in order to know whether to have this be -90 or 90 for rotating the door on the z-axis. And we will do this with what are called dot products. If you haven't checked it out already, I covered opening doors that always open away from you on my YouTube channel, youtube.com/copdev, which you might have seen promoted at the bottom of the screen there. On my YouTube channel, I do free UE4 tutorials and series. If you'd like to go check it out, that'd be great. If not, that's totally fine. And let's just continue with this door right here. So what we're going to do is we need to get our location of our player to calculate the dot product. So if we right click and we type in player ref, we can get player ref. Now where does this come from? If you remember in BP interaction, here at the begin play, we casted to our character and we set it as a variable. I mentioned that we'd be using it in the future. And it's a variable here down at the bottom under variables. But if we go to our BP interaction outward store, which is a child of BP interaction, we don't see it in our variables. If you'd like to see it, you can click on this eye right here and show inherited variables. Now this will add quite a lot, but most of it is organized into these. So we just have our isDoor closed, which we created for this specifically, and our player ref. And that's where we get it. So we want to get the actor location of our player ref. Now we need to subtract this from the location of our door. So if we right click and get self, we can get a reference to self. And off here, we can also type get actor location. And then we can take this and subtract vector minus vector our player ref get actor location. Now let's pull this back a bit because we're going to need some more room. First thing we want to do is normalize the vector. And then we want to get a dot product from this normalized vector to the door forward vector. So we can type in get actor forward vector and plug that in to the B of the dot product. Now we can pull this over, and we need to promote this to a variable because we need to reference it. So pull off, promote to variable, and we'll just call this dot product. And after here, after setting is door closed, we'll set the dot product before we get started, and we'll go ahead and play from start. And I'll change this is door closed from reverse to reverse till end. Also, in order to move these paths that have already been set, if you hold down the control button or command if you're on a Mac and click it, it allows you to transfer which execution pin you are putting it in. So I'll change it from reverse to reverse from end. So basically, when this updates, we just need to ask whether this should go from -90, or whether it should go to -90 or 90. So we can do it by dragging off here and getting a select node. And basically what we're going to ask is this dot product greater than or equal to 0? Because this dot product will give us a value of -1 to 1, letting us know which side we're on of the door. Oh, we're getting an error because we didn't plug that in for the index. But basically, we can show this by getting the tick and printing string. The string we want to print is this dot product. So we can just plug that in right there. Let's also expand this and change the duration of the print string to delta seconds so it doesn't flood our entire screen. Compile and save. So if we hit play, wait for that Shift F1 for mouse cursor to leave so we can see it. Oh, we're not seeing it. Why is that? Oh, obviously, this is not the correct door. This is the door that opens one way. We did not drag out our outwards door. So now if we hit play, we can now see it says 0.9. And as we move farther away, it'll get closer and closer to 0.1. Oh, and I fell off the edge. And as we get closer to it, we're going to get closer to 0. And as we pass over, it goes in the negatives. And the same thing happens on this side. And it gets closer and closer to -1. So basically, we just have to check if the number is positive or negative to decide which way the door should swing open. So back in outwards door, we can delete the tick and the string. Off this select, if the dot product is greater than or equal to 0, or if it's positive, then we want to rotate it 90 degrees. And if it's negative, we want to rotate it -90 degrees. So let's compile and save. Let's test it out. So let's hit play. And let's interact with the door. And it's opened away from us. We can press it again to close it. Now on this side, interact with the door. It opens away with us again. And we can close it. We can also open it, go over to the other side, and close it regularly. It doesn't jump to the other side to close. And the reason it doesn't do that is because we set our dot product as a variable right here, and we're using it as a variable when it decides to open or close. If we had just plugged this in directly without making it a variable, so if we make this obsolete, compile and save, and we interact with it, and if we go to the other side, our dot product has now updated to being negative. So we try to close it, you see it jumps to the other side, and that looks very bad. So we want this to be set as a variable just for when we open the door, and it doesn't update again until it's opened again. And we will set that there. So now we have a door that always opens away from us. Much better in my opinion. If you want to hear me go over it again, I have this, once again, I have this on my YouTube channel, along with many other tutorials that you could go check out at youtube.com/compdev. So while we're on the topic of doors, let's go ahead and make a third type. Let's make one that's physics-based rather than animation-based. One where you can grab and open with the movement of the mouse, similar to the classic horror game Amnesia. So if we go into Blueprints, our Blueprints folder, Actors, this will not actually use the BPI interaction. Speaking of all of this, we can close it all. It's getting kind of cluttered. I'm going to leave L1 character open. This will not use the interaction interface. We're actually going to be creating a second one for that, for our left mouse click, since we'll be using a separate button. So let's right click and let's create a new folder, and we'll call this grabbable. So we have our interaction actors, and we have our grabbable actors. We'll be adding more other than just the door in the future, which is why I'm making a folder for it. So let's create a blueprint class of type actor, and we will call this BP physics door. And like always, we have to add our static mesh, and we can call this door frame, and it'll be our door frame. And once again, add a second static mesh. Oops, there we go. Call this one door, making a child of door frame. Make the mesh SM door, and move it 45 units on the y-axis to center it. So let's compile and save. So we need to enable physics on our door. Not our door frame, this will not be physics based, but we do want to enable it for our door. So if we scroll down, we have this physics tab, and we can check simulate physics. There's a couple parameters we need to change. One is the mass. It automatically calculates the mass. As you can see, it's 29.22, but we want to enter it manually because I don't believe 29 is enough. So if we just check this, we can change it manually. I'm going to make it something like 150. We also want to bump up the angular damping, which will kind of smooth out and slow down its angular movement, because it definitely, at its default of 0, it definitely feels like it swings way too easily. So we want to up this to something like 4. We don't have to worry about linear damping because it doesn't actually move in a direction like that. It only rotates. And to make sure that it only rotates on the z-axis, nothing else, we can open this constraints tab, and we can lock the positioning for x, y, and z, and the rotation for x and y. So now the only thing it can do is rotate on the z-axis. This is great, but we don't want it to be able to rotate farther than 90 degrees. We don't want to be able to hold in, start doing this with our door. Set that back to 0. So to do this, we add what's called a physics constraint. So let's search for physics, and right here we have physics constraint. It doesn't need to be a child of our door frame. Yeah, it can be on its own. So here in our physics constraint, under the linear limits, they're all set to locked. That's fine. We can close that. In angular limits, we only want the swing 1 motion. So let's change our swing 2 motion, our twist motion, to locked. Our swing 1 motion will be set to limited, and the limit we want is 90 degrees. If we look, this actually changed the little icon down there for our physics constraint. If we change this again, you can see it updates with it. So change that back to 90, and that's what we want. So we need to let the physics constraint know which items, which meshes to affect. So if we go up here, under constraint, we have these component names. So for component name 1, we want to take our door frame name. So we'll type in door frame. And you can see it's highlighted our door frame. You need to spell it the exact same way it's spelled up here, which is why we named them manually. And you'll know you do it right. You've done it right if it highlights it. So for component name 2, we're just going to use door. And it's highlighted this one in blue. We also here want to choose disable collision because we don't want these two to collide with each other, because that can create some physics problems. They'll still collide with everything else, but they will not collide with each other. Let's turn down our projection angular tolerance to 90, and we want to move our actual physics constrained position to the correct location, which is Y45. Now for me, when I created it, I accidentally created it as a child of the door, so it automatically moved it to Y45, but if you didn't, it would still be in the center. You want to keep it on Y45, where the pivot is of the door. We can actually test if this is working now, just by dragging our door into the world and walking into it. So if we walk in, we can see it's opened up physics-based, and it stops at 90 degrees. It doesn't go farther than that. And it's the same on the other way. Great. So for grabbing this, we're actually going to be using a different interface called BPI Grab. So if we go to Blueprints, Init Interfaces, we want to create another one. So Blueprints, Blueprint Interface, BPI Grab. Open it up, and we're going to rename this function Grab Object. We will also need a second function for this, so we can click Add New Function. This will be called Release Object. And we can compile and save. So we want to use our left mouse click for grab. To do that, we'll have to add another input. So let's do Edit, Project Settings, go down to Input, and we want to add our action mapping. And I'm going to just call it LMB for left mouse button. Type in left mouse button, and we can close that. So in our L1 character, we can create input LMB, and when we press it, we can create a line trace. And that's why we made it a function, so we wouldn't have to just keep copying over all this code. I'm going to keep the length at 350, since it's also like a reach, and we can change the debug type to for duration, just to test that pressing the left mouse button now also creates a line. So this is me clicking the left mouse button instead of E. Okay, so back in here, and we can change this debug type back to none, and we're essentially going to do the same thing right here, where we want to copy and paste this. Basically, we want to ask if the hit actor is valid again, and if it implements the interface BPI grab. If so, we want to call the function grab object under BPI grab object message. That's what we want. Plug that into true. Compile and save. Before we continue, we want to actually promote this to a variable, this hit actor right here. Promote to variable, and we will call this grabbed object. Now we can click on it, and we actually want the variable type to be object instead of actor. So just search for object, scroll down, and choose it right here. It'll give us a warning because it's plugged into something. Just press change variable type. We shouldn't get any errors. Compile and save. So let's add this to this right here. And just to keep things clean, we can plug that in there and break the link to the line trace. Compile and save. So now let's actually add this interface to our BP Physics store. So let's open it up. Click on Class Settings and Implemented Interfaces. We want to add BPI Grab. Now over here, under Interfaces, we've now created these two functions, Grab Object and Release Object. So under Grab Object, right-click and choose Implement Function. And we can call a print string to test, like always. And we can say hit a grabbable object with our left mouse button. Compile and save. So we press play, we click on anything, nothing happens, but if we click on our physics store over here, hit a grabbable object with our left mouse button. Great, so let's go back into our physics store, and we can just delete this string. And what we want to do when we first grab the object is we want to disable our ability to walk around or move the camera. Because if we grab the door and we move the mouse to open the door, we don't want our camera moving with it, because that'll become very annoying and very hard to use. We also don't want to be able to walk around while this is happening, so that you can't walk very far away from the door but be able to continue to open it. So, right click, get player character, and then we want to get movement, get character movement down at the bottom there, and we want to disable the movement. Plug that in. Next we want to get player controller, and we want to set ignore look input, and we want to set that to true so we ignore our input. So we can test this out. If we go into our level, we press play. I'm clicking on doors, the non-physics doors, nothing's happening. But when we click on this physics door, I can no longer move around, and I can no longer look around. I'm pressing the WASD keys, and I'm moving the mouse, and nothing's happening. So next we want to enable the input directly in our physics store. Let me just delete these three while we're here. So off of get player controller, we want to enable input. Plug that in. Now the target is this, not the player controller itself. So if you remember, if you hold down control and click this, we can move this to player controller, and self becomes the new target. So now, after grab object is called, we can now have the ability to call inputs from this actor. So if you right click and we input look right, if you remember, this is the axis input we made in the beginning, which is our mouse X, moving our mouse left and right. From this input, we will call a custom event. So right click and add custom event, and we'll call it move door. Let's add an input to it, and we'll call this just amount, and we'll make it a float. And from this amount, we want to make a rotator. Instead of X, we want this on the Z, because we want the door to rotate on its Z axis. So let's drag in our door, and we want to set the relative rotation, and we want to set the rotation to the current rotation plus this amount. So off of door, we'll get relative rotation, and we can call combine rotators. This will be the A and B, and the return value will be the new rotation. Compile and save. Now we just want to call move door from our input axis look right, and our axis value will go into our amount. We'll compile and save. Now we just need to be able to release the door once we start being able to move it. But we can test it out before we implement that. So once again, everything's fine. I can click on these doors, nothing happens. I can walk around. Now when I click on this door, I can no longer walk around. But when I try to move my mouse, moving it right and left will move the door right and left, instead of moving my camera. But there's no way to get out of it currently, so that's what we need to add now. So in our L1 character, right here for L and B, when we release our mouse, we want to call the release object. So we have to get our grabbed object. First, let's ask if it's valid. Make sure we actually do have a grabbed object. And if it is, we want to call release object message. Plug that into the is valid. By the way, there is 2 is valid nodes. So if we drag off again, type in is valid. They do essentially the same thing. The one I clicked on was this little question mark. This is just converts it to a macro. Because if we get this one, it's just a Boolean, and then you could call an if statement. And this would be the true and false. So is valid, is valid, is not valid, is not valid. They do the exact same thing. So either one is fine. After we set call our release object, we want to set our grab object to null. So we don't want to set it to anything. So let's go back into the physics store and implement the function for release object. And basically we just want to counteract everything we set for grab object. So we want to re-enable the movement, and we want to re-enable the look input, and then we want to disable the input from this actor. So if we get player, let's go with character first. There's no node for just enable movement again. You can see there's nothing there. What we have to do is set the movement mode from our character movement. Because if there were just to re-enable the movement, it wouldn't know which mode to put it on. The mode we want is walking. This is just our default mode. It's the one we've been using, and we don't need to use any of the others. After that, we'll get our player controller, and we will reset ignore look input. So it'll reset it to allowing us to look around. Then we want to disable input. Once again, we don't want this in the target, we want this in the player controller. The target is self. Compile and save. So let's test it out one more time. We can control it and we cannot move around or look around. And we release, and we are back to our normal state. And it feels very nice. There's one small issue. It feels kind of awkward, in my opinion, being on the other side of the door. I feel like when I move my mouse to the right, it should open outwards instead of come inwards. It feels fine on this side, but I feel like it should be inverted on the other side. This is, of course, personal preference, but I'll show you how to do it in case you agree. So to do this, we're going to be using the same logic that we use in our outward store right here to get our dot product. So we can just copy and paste this right here. So I'm going to copy, and let's go into our physics store, and we need to paste it for our move door custom event. So I'm just going to move this released object down a little bit, and I'm going to hit paste and bring this over. Basically, we need to know whether to multiply this amount. So we can get a multiply. Say float times float. Plug this into a z. We need to know whether to multiply this by 1 or -1 to invert it. So we can get a select node off of that. And the wildcard here, similar to the outward door, is just checking if this is greater than or equal to 0. And we'll plug that into index. If I can grab it. There we go. If this is true, we want to multiply it by 1, which is basically making absolutely no difference. And if it's false, multiplying it by -1, which inverts it. We can compile and save, and we have an error. And that's because we don't have a player ref. For this, we can just delete it, and instead get our player character, and plug that into get actor location. Compile and save. So let's test it out now. If I hit play, it can open. I pull to the right and it opens the door. Pulling to the left, it opens the door towards me. Go to the other side, and pulling to the right opens the door again. I feel like that feels a lot better. Now, if you want to open the door slower or faster, basically want to adjust the sensitivity, we have to add a multiply node here in physics store in this look right. Pull this off, get a float times float, and we can just adjust this number. So if we want it a lot slower, let's do something drastic like 0.1, so it's only 10% of what it would be. Press play. I'm gonna try to pull it around the same amount I have been. It only opens about that much. basically pulling this across my entire mouse pad right now. If you want it to be more sensitive, you know, you would do it like something above 1, like 2, which I definitely wouldn't advise because 1 itself is already pretty sensitive. I'm going to change this to maybe 0.6. We can see how that feels. And I think that feels pretty good. Alright, let's make some updates to our level here. Since the next thing we're going to be working on is our flashlight, we can't have this bright scene going on. This is going to be very fast, very rough, not an optimal way of creating a level, because we will be getting into more in depth of level design later in this course. So first, I'm just gonna duplicate these. If I hold Alt and then adjust it, it duplicates it. And I'm gonna move this over here. Create another one. Move it over here. We're just gonna make a quick room real quick. Hold down Alt again. Duplicating those. Pulling these in. Okay. And I will duplicate this as well. And now we have a room. We don't need any of these exterior lights, so we can just click here. We can delete this sky sphere. So it's gone. We don't need the atmospheric fog as well. Delete that. And we don't need this light source. Delete that as well. I guess we don't need the skylight or the sphere reflection capture at the moment either. Just because this is a really rough scene, we just want it dark. Now we're still getting some light here, even though we don't have a single light in the scene. And that's because we need to build our lighting. So right here under build, if we click this little arrow, we have this option to build the lighting only. We can also change the lighting quality from anything from preview to production. The higher it goes, the longer it'll take, but the more quality it'll be. We don't need anything high right now, because for one, this lighting will look the same regardless since it's going to be pitch black. But as we add lights, we'll probably increase it a little bit, and then at the very end, we will do a production and see how it looks. So let's just build the lighting. And as you can see, it is now completely pitch black. If we want to be able to see in our viewport, we can click lit right here and change it to unlit. And now we can see everything we need. I don't want it completely pitch black though, so we're just gonna drag in a point light from the side here. If you click in lights, it'll be right there. And we'll just drag this to about the center of our scene. Go to details. Gonna increase the radius a bit. Doesn't need to be that big, actually. Let's do, yeah, no, 1,000 is fine actually. Increase the intensity just a bit, like 10. And maybe make like 2 of them, just so we can see. It is a pretty awful scene, if I'm being completely honest, but like I said before, this is very temporary. We just need something dark so we can test out our flashlight. If you want these point lights to be completely accurate too, you'll have to build the lighting again. And here's what it looks like after the lighting has been built again. Alright, so let's create the thing that all horror games have, the flashlight. So let's open up our L1 character right here. So what we want to do is add a spotlight to our camera. So we search for spotlight, we can add it, and let's put it under our camera. Putting it under our camera will allow it to move left and right and up and down when we look left and right and up and down. Let's also change the transform to 0 so it's perfectly in our camera. Now if we were to hit play, we can now see we have this light connected to our camera. It makes much more apparent when we go near walls. Okay, but this doesn't look much like a flashlight. To make it look more like a flashlight, we have to add what's called an IES light profile. Luckily for us, there is a free pack of IES light profiles in the Epic Games launcher. So if we pull up the Epic Games launcher and we go here to Marketplace, and we can search for IES. We get this oh, not this one. We get this IES Light Profile Pack from Construct Games. It's under the permanently free collection, so you can just go ahead and download it and add it to your project. So I'm going to add it to mine. Just click Add to Project, Udemy Horror Game. And I'll wait for that to load in. Alright, that was pretty fast. So now if we go to Content, we now have this new folder called Light Profile Pack. And if we click on Lighting and Profiles, you can see all these different way it kind of shapes our light. What I personally think looks best is Capped 2 right here. So I'm going to select it, and then in our element character, our spotlight here, I'm going to scroll down, and here we have IES Texture. Since I have it selected in the content browser over here, I can just click this little arrow, and I use the selected asset. I'm also going to check Use IES Intensity. So this is going to let this texture here control the intensity of my light rather than controlling it manually right here. As you can see, this has become grayed out because we checked it down here. Let's compile and save. If you want to change the degree of the intensity, we can, or the scale is a better word, we can change it here. So if we were to hit play right now, we have our spotlight, and as we get closer we can kind of see how it gets more intense based off the different sections of our flashlight. If we were to bump this up to say like something drastic like 5, you can see it's a lot more intense. And it gets very washed out when we get close to walls. I'm going to leave it at the default of 1. I will, however, change the attenuation radius to 1200, so we have a bit farther of a reach. So, lastly, the flashlight here seems a little static. It's perfectly centered to our camera, and it follows us perfectly. We want to make it look a bit more natural. So we're going to add what's called a spring arm. So under the camera, we're going to add a component called spring arm. And this creates that little red line that kind of looks like those line traces that we created in the last few episodes. What we're going to do here is actually make the spotlight a child of the spring arm instead of the camera. Now this actually attaches the spotlight way over there at the end of the arm right there. So we need to adjust the arm. So the target arm length is going to actually be 10, and then the socket offset is going to be -30 in the z-axis. So this puts it slightly behind and slightly below our camera. I feel like this makes it look a bit more like it's in our arms rather than coming straight out of our eyeballs. We can see how that looks when we press play. It's very hard to see a difference at the moment, but this isn't actually the main reason we attached a spring arm, because you could just change the location of the spotlight itself. The main reason we have a spring arm is if we go down, we can select Enable Camera Rotation Lag. Turn that on. Now this is what really sells the magic for me. If we go ahead and hit play now, there's going to be a bit of a lag between our camera movement and the flashlight movement. As you can see right there, the flashlight takes a second to catch up with us. This gives it a much more natural feel and makes it seem much more alive, in my opinion. You can change the speed of the lag with this camera rotation lag speed. I really like the default, so I'm not going to touch it. But for, well, I guess for a default example, I can show you. If it's 5, it's a little slower. It takes a little longer. And if it's 20, it's much faster. Almost non-existent. I like 10. And we can do one more thing right before we wrap this one up. If we go to Project Settings, down to Input, we can create a action mapping for flashlight toggle, and we can make it F, close the gamepad, make it F on the keyboard, and just create a input flashlight toggle. And we can just toggle our spotlight on and off. So we can set visibility. Pressed, we want to set it to false. And we can get visible and create a branch. So if it is visible, we turn it off. And if it's not, we can copy and paste this and turn it back on. And make sure we plug this into the target. Cool. So now if we go back to our level, we have our lag. If we hit F, it turns it off. F again, it turns it back on. We can now toggle it. Alright, that'll be it for this episode. So what kind of horror atmosphere would it be if we didn't have a couple of flickering lights? So there are two ways to do this. One with simple re-triggerable delays, and one with light functions. I'll be showing you how to do both because there are pros and cons to both. So first we will start with a light function. So let's add a folder and we'll call this materials. Open it up and we will make a material and we'll call this M light flicker. And we can open that up as well. We want to change the material domain from surface to light function. And that eliminates all our inputs right here to just a mess of color. Alright, so this is a fairly simple material. We just want to get the time node right here. And we want to multiply it by a constant parameter. So if you hold down the 1 key and you click, it'll create a constant. Otherwise, you could just right click and type in constant. Now we want to right click on the constant and press convert to parameter. And we will call this speed. This will be the speed of our light flickering. I'm going to make the default 1 and plug that into the multiply. Bring that farther back a bit. We have to run this through a sine node and run that through a frac node. And then we want to clamp the intensity. So get a clamp, and for our min and our max, we'll hold down 1 and we'll create a constant. We'll make another one. We're going to convert both to parameters. We'll call this one min intensity, and this one max intensity. So when our light is flickering, it will only go between our values of 0 and 1. If we change our max intensity to 1. And these can be altered, of course. And let's plug this into the min and the max, and plug this into emissive color. And all of a sudden, it starts flickering. And we can mess with these values. So if we change the min intensity to something like 0.7, and hit save and apply, it'll apply automatically. It is now going between values of 0.7 and 1 rather than 0 and 1. With this light specifically, it's pretty hard to tell just with this sphere right here. So let's go ahead and add it to one of our point lights. So let's take this point light. If we scroll down, we have our light function material right here, and we can drag this in. It's much easier to tell when it's actually connected to a light. So this is a value between 0.7 and 1. Let's make a material instance of our material right here, so we don't have to keep going in. And we'll just call it inst, open it up, and we can check all these 3 things, save, and let's replace our light function material with the instance. It'll look the exact same because we didn't make any changes. But now if we go into our instance and change the min intensity to 0 again, hit save, we can now see it goes between 0 and 1. It gives a much more intense version of a flicker, but also much more distracting. It depends what you want. It depends what works for your horror game. I'm going to leave this back at 0.7. We can also adjust the speed. So if we change this to like 5, it'll become a much faster flicker. This is more accurate probably to real life flickers, at least to how I've seen them. Once again, it depends on what you want, and it depends on your game. So you can continue to make instances if you want to just keep changing the values for different things. These are values I like, and we have a good flickering light. Now the cons of using a flicker like this is it's not technically random. It does look good, but it is a pattern. It's not truly random. That's why I'm showing you the second version, which is truly random, and that'll be a blueprint version. So if we go into blueprints, actors, we can right click, create blueprint class, actor, and we'll call this BP flickering light. Open this up, and we can add a point light, compile and save, and in the construction script, grab our point light, and we want to set intensity to a new variable. So we can just right click on new intensity here, promote to variable, and we'll call it intensity. Let's make it 5,000 by default, because that's the default intensity of our point light. And then in event graph, on begin play, we're just going to be calling a retriggerable delay. And every time this is called, we are going to adjust the intensity of our light. So the duration of this delay, we want it to be random. So we'll get a random float in range. And we can promote both of these to variables. So we'll call this min time and max time. Values I think are good. We'll have to compile it first. Are 0.1 seconds and 0.3 seconds. So a random number between 0.1 and 0.3 is when this will be called. And we want to get a flip-flop node, which means it'll choose A, and next time it's called it'll choose B, and then back to A, and then back to B. So on A, we want to get the point light and set the intensity. And this new intensity is going to be our fourth and final variable, and we're going to call it min flicker intensity. And we'll compile, and I'm going to set this to about 3,500. So this is the lower side of the intensity, because our default is 5,000. And then on B, we want to set the intensity of the point light back to its regular, which is our intensity variable right there. After both of these are done, we want to recall the retriggerable delay. So we can just drag this over here, and we can kind of pull it up to kind of see what's happening here. We can double click on the path to create a reroute node, and that can clean things up for us. So pull that down there, create another reroute node, and that makes it a lot clearer what's going on. And this set intensity will plug right into this reroute node as well. So after both of these, we call the delay again. It waits a random amount of time, and then it'll set it to a lower intensity or a higher intensity, depending on which one it did last. So we can compile and save. Before we exit, let's change all of these variables to editable by clicking this little eye icon. If we can compile and save, we can drag our flickering light into the scene. Yeah, let's leave it somewhere right there. And here on details, because we made it editable, we can change all these values. So we can change the default intensity. It'll update in real time because we put it in the construction script. I'm going to leave that at 5,000. Oh, it's 500. Once again, typed 500, 5,000. And we change the minimum, which is kind of the same thing of changing the min and max intensity here between 1 and 0.7, but here we change it between the actual values. So we hit play, turn the flashlight off. You can see this one is actually truly randomly flickering. It's a little slow at the moment. We might need to speed it up. Now, the pros of this, obviously, is that it's actually random. The cons is that it is more of a toggle between two intensities rather than a fade like this one is. This one fades in and out between the intensities, while this one toggles. To make it look better, we could speed it up a bit, so we could make the min 0.05 and the max 0.15 maybe. Hit play. And now it's a bit faster. So ultimately, it's up to you which kind of light flicker you'd prefer to use. Both have their advantages, both have a couple disadvantages, or I guess not a couple, but just one each. So you can decide what is right for you and what is right for your horror game. So since we were working with interaction objects lately, and we only have doors plus the parent, but that doesn't actually do anything, let's create another type of interaction, and that'll be interactable lights. So essentially a light switch. So let's make another child of BP interaction. So right click, create child blueprint class, replace the word child with light switch, and open it up. We can just use this box again since we don't have a mesh. You can obviously replace if you do have a light switch mesh, which you should get one if you're planning on making an actual game. We'll just resize it. So maybe 0.5. And well, let's pull this one up just a touch. 0.2. And 0.05. There we go. That's about light switch shaped. We need to know which light we want this light switch to interact with. So we'll do that by creating a variable, and we'll call it light. And the type will be just light, right here. Now it's important that we make this editable, so we can assign what light we want it to be in our world. If we actually place our actor in our scene now, let's go ahead and bring that over there. Cool. We can choose which light we want. And we can use this little eyedropper tool to directly click on one. So it doesn't let us click on things that aren't children of the light class. But let's go ahead and choose this light right here. So now this actor can now reference this specific light. So let's go back into our light switch and into our event graph. And we want to get open interfaces, and we have our interact here because this is a child of BP interact, and implement the function. So we want to get our light and get light component down at the bottom here, and set is visible, or set visibility to false. And we're essentially doing the same thing we did with our flashlight. We can just get visibility, or get it's visible, create a branch. If it's true, we set it to false, and if it's false, we set it to true. And make sure our target comes from our light component right there. Compile and save. Now, if we go in, start our flashlight off to make it easier to see, and we press E on our light switch, it turns this light off. The flickering one is still on, and I deleted that blueprint one. And press it again, turn it back on. We now have a light that we can toggle with our switch. I'm going to bring this a little further down so we can reach it a little better. There we go. Lastly, we can do something just to fix a couple errors. Say you have a light switch that isn't assigned to a light. So if we click this little yellow arrow here, changes it back to none, and we try to interact with it, and we stop, we get errors because it doesn't know what to interact with. To eliminate this, we can go into our light switch, and before anything, just grab our light variable and ask if it's valid. I'm going to be using the macro here. And if it's valid, we continue. If it's not, we won't do anything. So now we can see it's still set to none, doesn't have any lights assigned to it. And we press E on it a few times, and we exit the game, no errors. But let's grab the eyedropper tool and put this back on a light so it actually does the thing we programmed it to do. And we can turn it on and off. Great. That is how you make a light switch. Alright, so let's expand on our movement a little bit by first adding sprinting. So first thing we want to do is expand this map a little bit. It's a little too small to be able to sprint around. So I'm going to hold down Alt and drag the floor. It creates a new one, duplicates it. Also, if you hold down Shift while moving something, the camera moves with it. It's a good little tip. I'm going to change this to unlit real quick so we can see outside. And just pull this right next to the original floor. Cool. And I'll pull this wall out and hold down Alt and duplicate these as well. And same with the ceiling. Okay. That all looks good. We can bring some lights over there. Alright, and if you want, you can go ahead and build the lighting again. Alright, now that that's all done, let's go into our blueprints folder right here. And I want to make a new folder. We're going to call this blueprint components, because we're going to be making this a blueprint component, and or an actor component, I should say. And an actor component is something we can make that we can attach to different actors. In this sense, we'll be attaching them to characters specifically. So let's go ahead and create it. So right click, blueprint class, and actor component right here. And we'll just call it BPC for blueprint component underscore movement, because this will handle our sprinting and our crouching in the future. So I'm going to open that up. I'm going to close our light flicker stuff. Save. So I'm going to use the event tick real quick to kind of show you how this works. So off the tick, I'm going to print a string, and we're just going to call this or let's call it BPC movement is active. Compile and save. And if we go ahead and hit play, we won't see anything in our tick because this component is not attached to anything. So let's open our L1 character, and here, where add component, we can now search for BPC movement, and it goes down here under character movement. Compile and save, and now that it's attached to our character, which spawns into the world, BPC movement is now active. Great, so let's remove that string. So let's create a function. This will be the initialize function. And we can give it an input of character. And we can just call it character as well. And we can promote this to a variable, and we'll call it player ref. Compile and save. We're doing it with this function like this so we can avoid casting. And while casting isn't necessarily a bad thing, it is a little expensive on our computer. So when there are workarounds, we definitely want to use those workarounds. So I'll show you how. So in our L1 character, because we've added BPC movement to our character, in our event graph, or in our L1 character initialize function, we're going to pull this down, and we're going to make a sequence, and we're going to pull these widgets to the then one. So this will happen second. First, we can get our BPC movement, and we will call the initialize function from BPC movement. And there's our character input that we added right there. And we just can get a reference to self and plug it in. This way we don't have to worry about casting. Compile and save. So back in BPC movement, we can go to the event graph, and let's create some variables. First, I'm going to just close all these, which are just the inherited variables. that we have right here. We can turn them off if we want. I'm just gonna leave mine on. Oops. But let's create a new variable, and this will be called sprint speed, and it'll be of type float. And we also want to make sure it's editable, so we can easily change it in our L1 character. So here on BPC movement, we can just click on it, and we can adjust the sprint speed right here. Took me a second to find it. So back to BPC movement, I'm gonna default it to 800. That'll be our sprint speed for now. Let's also create our walk speed. Let's go ahead and make that editable as well. And we're going to use this variable to set our walk speed at the beginning. So if you remember, in the beginning, if we click on L1 character movement, we changed our max walk speed to 400. So it's a little slower than the default, which is 600. So let's set our default walk speed here also to 400. And what we're going to do is in this initialize function, off the player ref, or we can just drag in a reference right there, we can get character movement. That should be at the bottom. And we can set max walk speed to the walk speed. So now, in the very beginning, when we start our game, our walk speed will be updated from whatever it is in our BPC movement. So if we change it here to like something crazy like 1200, we hit play, we now walk at a speed of 1200, which is super fast. But I was just making it that fast to demonstrate. So we can change this back to 400. So we need 3 more variables after this. It'll be our max stamina, our current stamina, and our minimum stamina. Just do min stamina. Our max stamina, we're going to make it editable, and we're going to make the default 100. It's editable, so you can easily change what you want. You can make the min stamina editable as well, but in most cases, I just realized I adjusted the min stamina and not the max. So let's change the min back to 0 and the max to 100. But like I was saying, you could also make the min editable if you want, but in most cases the min will stay as 0 and will not be updated or adjusted, but it's up to you. So we can compile and save. I'm going to keep mine off. Current stamina we can actually make private because we don't need to reference this variable in any other blueprints. So let's go into our event graph, and we can delete these 2 for now. We're going to make a custom event called start sprint. Now we only want to be able to start sprinting if our max stamina, or no, not max stamina, our current stamina is greater than our min stamina. So first we just want to check, do we actually have stamina? Let's do an if. And if we do, then let's grab our player ref, get character movement, and set max walk speed to our sprint speed. If we want, we can select these 3 right here, right click and collapse to function, and we could just call this set player max walk speed. So we can reuse it, open it up, and take this max walk speed and drag it onto here to create an input. Compile and save. Back in the event graph, we now have a function, and it'll be a little easier to reuse. So after we set the speed to sprinting, we want to call a timer. So we'll set timer by function name. And this timer, what it'll be doing, it'll just be depleting our stamina and then checking to make sure we haven't hit 0. So the function name, we don't have the function yet. So let's create it by right-clicking, creating a custom event, and we'll call this sprint timer. Now back in the set timer, we'll type in also sprint timer. you have to make sure that this name right here is spelled exactly the same as the custom event here, or it will not work. So let's set the time of the timer to 0.1, and we want to make sure we've checked looping. Now the time here, this is the amount of time that passes before this function is called again. So this way, this function is called every 0.1 seconds, or 10 times a second. Now in here, we can actually prove it by just doing print string and say timer was called. And let's make it something we can tell more, so let's change this to 1 second. Compile and save. And an L1 character for a debug here over here. Let's hit C, and it creates a comment. We'll call this debug, so we know that everything under this comment is just for debugging purposes, so we can remember to delete it later. We can do input 1. So if we hit the 1 key, get our BPC movement, and we will call start sprint. Compile and save. And remember, start sprint starts the timer. So if we hit 1, nothing happens. And this is because our current stamina is set to 0, and it is not above our min stamina. So this is currently going out the false node, which nothing continues. So let's set our current stamina to, let's say 100, which is our max stamina. Try again, hit play, and we hit 1, and every 1 second the timer is called. Now it looks like those two are just being static there, but that's because the print string stays for exactly 2 seconds. So every time one is removed, it's at the exact same time another one is added. So maybe 1 second wasn't the best time to use because it made it look like it stopped, but it didn't. So let's change this back to 0.1. And we can delete the print string, compile and save. Let's also delete our debug. And in sprint timer, we want to subtract the 1 from the current stamina every time. So let's get current stamina, and we want to subtract 1, so float minus float 1, and then we want to set the current stamina to that amount. But instead of just plugging that into that, we want to get a clamp which doesn't allow it to go above a max value or below a min. I'm going to plug the return to there. The min value will be our min stamina, and the max will be our max stamina. So it can never go above currently what is 100, and it never go below 0. Compile and save. So what we have at the moment is every 0.1 seconds after we start sprinting, it subtracts 1 from our current stamina. So it subtracts 10 a second. Now we want to check if it hits our min stamina. So let's create a branch, and we want to ask if the current stamina is less than or equal to our min stamina. Now it never technically should be less than because we clamped it, so it should always just clamp to 0, but it is just feels like a safer way to do it since it's always going down. And if you put exactly equals, I'm just the type of person to get paranoid that it's going to be, go down to like negative 0.0001, and it will not work. So I just like to do less than or equals to min stamina, and we'll put it in there. And if that's true, we want to call our third custom event, which we can make now, and we want to call it stop sprint. And off the true, stop sprint. Now the first thing we want to do in stop sprint is stop this timer. We don't want to continue to deplete stamina. So we can do this with a clear timer by function name, and once again, type in sprint timer and make sure it's spelled the exact same as these. So that'll stop the timer. After that, we want to set player max walk speed to our walk speed. So back to a walk. And this is actually in a place where we can test it at the moment. So right before we test it, I want to be able to see what our stamina is. So let's, right in here, create a print string and plug our stamina into that. Compile and save. So let's go into edit project settings and down to input. And once again, we're adding another one, and we'll call this sprint. And this will be bound to our left shift. Close that. And now in L1 character, our input sprint, we should probably start moving this horizontally rather than just vertically. We'll put it here. Input sprint. On pressed, we want to get our BPC movement and we want to call start sprint. So let's test it out. Let's press play. And we can walk around like normal, everything's the same. And we press the shift and we speed up. And you can see our stamina is depleting on the left. And it's going down, we're moving very fast. And once it reaches 0, we go back to our walk speed. We've gone back down to 400. Great. So this all works as intended. As you can see before, we also were not able to start sprinting again once we ran out because our stamina was 0. But that was demonstrated in the beginning, but I can demonstrate again right here. We've gone back to our 400 walking speed, and hitting sprint does nothing. So let's make it, if we release the sprint button, we stop sprinting. This is as easy as going into L1 character, and off the released, just calling stop sprint. Compile and save. So now, if we press play, we hold down shift, and we stop. Our stamina is now at 78, and we're back at our 400, and we start again, and it starts from 78, now it's at 55. Stopped running, and so on and so forth. Before we make the function to regenerate stamina, there's a couple issues. One is if you hold sprint while standing, our stamina still goes down. So if I hit play, and if I don't move with WASD, and I just hold sprint, our stamina depletes. We don't want that because we're not actually moving. So in BPC movement, we want to add a AND Boolean for this first branch here. Let's pull this off, type in AND. So that's to check if both this and this are true, for it to go off the true path, of course. And for the second, we have to get our player ref and get velocity and get the vector length of that velocity, and we just have to ask if it's greater than 0. So basically what the player ref's velocity vector length is returning is the actual speed we're going. So if we set the max speed to our sprint speed, which is 800, and we accelerate all the way at our full speed, this will output 800. If we stand still, this will be 0 and everything in between as we accelerate. So we just have to put this more than 0 to make sure we're actually moving. And once again, for safety measure, I like to put it just like something like 10. So we have to have had accelerated above 10, which, you know, happens in the fraction of a second. So if we hold shift now, it does not go down unless we are moving. And now it does. Now the second issue we have is if we hit play, and we start moving, and we hold down shift, and we stop moving, but we continue to hold down shift, our stamina continues to deplete. So we need to fix this as well. So we basically have to ask the same question for our sprint timer. Actually make sure we're still moving. So up here, let's drag this all down just a bit. And we can pull all this off to the right. And we want to ask if, and we can just copy and paste this right here. And plug it in. And off the false, we want to call stop sprint. So we can test that out again. and I move, I hold down sprint, I stop moving while still holding down sprint, but my stamina no longer depletes. Now lastly, we just want our stamina to be able to regenerate after we've stand still. So what we want to do is, after setting this walk speed, we want to set a re-triggerable delay for 5 seconds. So it waits 5 seconds before it starts regenerating, so it doesn't start going up immediately. And we want to first check, or let's get a branch. Started typing in just what I was saying. And we want to get a is timer active by function name. And function name, like always, is sprint timer. So we have to check if sprint timer is active. And this is because when we stop walking, or stop sprinting, I'm sorry, and it sets it back to walk speed, and then it starts to wait 5 seconds, and then it'll start to regenerate. But if you start sprinting again, within this 5 seconds, it will still start to regenerate 5 seconds later, even if you're sprinting. So you could be sprinting and your stamina could be going up instead of down. So we just want to check if the sprint timer is active, and if it's true, we won't do anything because we don't want to start regenerating our stamina. But if it's false, we want to set timer by not event, function name, and this will be a new function, our fourth, and this will be called I do that all the time. I type in what I'm going to call the custom event. We're going to type in custom event, create one, and we're going to call it regenerate stamina. And that's what we want to type in for function name. Make sure it's spelled the exact same. I'm going to double check real quick. Yep, looks good. And for the time, I want this to regenerate faster than we lose it. So I'm going to put 0.03. And we want to check looping. Now in regenerate stamina, we're basically doing the opposite thing we're doing in sprint timer. So we want to get our current stamina, and we want to add one, and then we want to set our current stamina to that amount, but once again we want to clamp it. Nope, not clamp angle, we want to clamp float. And the min is our min stamina, max is max stamina. And then we don't want to just have this constantly running even when we're full, so we just have to check if the current stamina is greater than or equal to the max stamina. Once again, it's the same thing. You could just use if current stamina is equal to max stamina, but to be safe, I'm using greater than or equal to. If this is true, we want to clear timer by function name, and we're clearing our own timer, so regenerate stamina. And make sure it's spelled the exact same. Okay, looks good. Before we can test it out, we also want to copy this, Command C, and we want to clear this timer on the start sprint. So after all this if, right before we set our sprint speed, we want to clear this timer. So if we start sprinting when our stamina is regenerating, it'll immediately stop regenerating the stamina, and it'll start our sprint timer, which depletes it. So now we should be able to test it out and see how it looks. So we still have our print string for our stamina, and we walk around normally and nothing happens, and we start sprinting and it starts going down. Let's have it go all the way down first to 0. Because we added a few things, so we have to test them all out. And after 5 seconds, it should start to regenerate. 2, 1, now. Oh, we don't have a print string for regenerating, of course, so we can't see it regenerate. Let's just add it right here. My apologies for that. So for regenerating, we also want to print the current stamina. All right, let's run it all down again, back to 0. And once it hits 0, after 5 seconds, it should start regenerating again. So 4, 3, 2, 1, and now it's regenerating much, much faster than it depletes. Cool. And we can sprint and start it over. Now if we sprint and stop about halfway through, 4, 3, 2, 1, it starts regenerating from that number back to 100. Now if we start sprinting and then stop, 4, 3, 2, but then start again, you see it does not start regenerating even though that 5 seconds has passed. And that's it. And the greatest part about it is how easy it is to tweak these variables. So we just go into L1 character, click on BBC movement, and we have all of these. So we can change the sprint speed, the walk speed, and the stamina amounts. I'll leave the staminas to 100 and 0. I like to work with those values. And if I want to make it, you would probably only want to adjust these if you had some kind of upgrades where you could gain more stamina throughout the game. But if you want to adjust the speed of the losing stamina and regenerating stamina, I would adjust these time values in the 2 set timers, which you could easily make variables just by right-clicking promoting to variable and then adjusting in here. It's up to you. One thing I will say though is make sure your stamina doesn't run out too fast. It's another common mistake in indie games. Many games will have characters with stamina that runs out almost immediately, which can be very annoying, especially because it doesn't feel like it would make sense in a horror game where you would probably have lots of adrenaline rushing through you. But also, in some games, you obviously wouldn't want to give them like infinite stamina. But it all depends on your game. You can also adjust the speeds as you wish. I feel like both of these are a little too fast for a horror feel. So I'm going to bump the sprint down to 500 and the walk down to about 250 and see how that looks for me. So now the walk feels pretty slow, pretty creepy. And the run feels fine in comparison. Now I feel like we aren't some kind of crazy speedster. This feels a lot better to me, so I'm going to keep it like that. Alright, that'll be it for this episode.